Chat. Hello. Hello, chat. I don't even know why I felt like streaming this was gonna be a good idea, but here we are. I just felt like I should stream. I've sort of wanted to just, stream a little bit more and be in the presence of, or semi-presence of the internet a little bit more recently. So today we're streaming, even though for the most part I'm probably gonna be doing boring stuff like studying and taking notes and learning. Chat, it's time to learn. It's time for the hyperbolic time chamber. Middle of the week stream? Correct, mystery. Weekday stream. That's why I'm doing I probably should be doing homework. But we're like really winding up some efforts at my workplace that are gonna be involving more model-based systems engineering. Big buzzword nowadays for the systems engineers, so and I sort of want to be part of them. And there's also some other, promotion opportunities. So I'm just trying to sharpen up a little, Sharpen up a little. What is that? So maybe this'll be a great stream to go over. Model-based systems engineering. So I don't know if you understand what the term systems engineering really is, but systems engineering is like a really broad sort of abstract sort of discipline within engineering, and it's kind of less technical than you would think of with engineering normally, but it has to do with what are called requirements. So it's sort of like setting goals is you create requirements for what you're gonna build, and then you meet those goals, right? You need to meet your requirements with whatever you build. So, for example, before there was the iPhone, right? Someone had to have the idea of I think we should build a phone that's, gonna be a touch screen. It's gonna include, iPod apps, blah, blah, blah. They start laying out ideas, and those are called, requirements. And then you start breaking it down of, okay, well, if it's gonna have a touch screen, it's gonna need this level of hardware. So then you end up with requirements for hardware, and then slowly, it's this whole process, right? But systems engineering in general is just sort of a more formulated process for what you might consider the whole design cycle. And model-based systems engineering is a sort of newer approach to it that involves what are called models. So it's computer models, and you probably, if you hear models, you're probably thinking of CAD models and whatnot, but that's not necessarily the case. These are more software models where you might think of object-oriented programming where you create sort of blocks. But this is sort of like that, where you're creating blocks of this is the block that represents our processor for the iPhone. This is the block that represents our touchscreen, and then you sort of link them together, and it keeps everything really well organized. I think it'll be easier to explain if I start going over it more. But it's a whole thing, right? I think for starters, the best intro is to just understand what systems engineering is. And I was just looking at a PDF of model-based systems engineering for dummies, which of course is focused on the model-based systems engineering stuff, because it's published by one of the companies who makes model-based systems engineering software. The best intro is knowing everything beforehand, I suppose. But I'm looking at the intro, and it has probably one of my favorite diagrams ever for systems engineering. It's done really well. It's called the Systems Engineering V. Let me show you. Let me show you what I'm talking about. If we do this question mark? Okay, you see the big V, right? It's a big upside down triangle looking thing. Wait, I know even better. We'll mark it up. Wait, hold on. We're gonna need to take notes anyway. Oh my god, is my monitor too small for this? Maybe not. Maybe not. Let me plug in my freaking drawing pad too. How are you, Rax? Computer? Okie dokie. So, on the left you see what's called the Systems Engineering V. You know, it looks like this. It's V-shaped. And I think if you were to Google this, you would see a bunch of stuff that were like little steps of like very specific things of like, you know, problem statement is here, you know, use case might be there, and then you slowly break it down into like system level requirements, functional requirements, and then system level performance requirements, and then you have subsystem level functional requirements and whatnot. It sort of breaks down, but they've got all sorts of like, everyone's gonna show you different steps for it, which I don't think is really that helpful because people get too caught up on the steps. I think just understanding like the general idea of what it is a lot more helpful. So what it really is it's a sort of like a plot of, on the y-axis. The y-axis is like how abstract, being like big picture, general, whatnot, and then as you get lower and lower, you get more detailed, right? Where the top level abstraction is just like, oh, well, we want to travel, and then it slightly lower would be like, let's build a car, and then slightly lower would be like the engine, and then lower than that would be pistons, and then eventually you get down to like screws at the very bottom is like where you end up. That's the y-axis. On the x-axis is sort of like time. It's like start of your like development process and end, right? So that's why I have this arrow, right? Like you're generally trying to like follow this. So the name of the game is like, you start with this broad idea of what your problem is. You brainstorm some, you know, greater level idea of how your solution is, and then you're gonna start breaking it down into like, what does that solution require? And then how do you get there with smaller levels of hardware? And then what do those smaller levels of hardware require? And you're just, on this side of the V, as you're going down, you're coming up with requirements, right? You're setting goals for yourself of like, okay, well, I think we need this, 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 right? I think we need an engine with 500 horsepower, and in order to achieve that, I think we need 6 pistons, and I think we need pistons that are this size, and I think we need them to be made of this material, and blah, 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 right? So that's your going down, creating requirements, or setting goals for yourself. And then at the bottom, right, is when you've got like a fully fleshed out design or idea, and then you start building it. And as you build back up, you do all the same processes, except instead of creating requirements, I'm just spitting out numbers. I'm just spitting out numbers, mystery. I don't know what's reasonable or not. I don't do cars. But on the way back up, instead of like creating the requirements, now what you're doing is you're making sure you met them. So you're going to start with like, you're gonna start by looking at all the screws you bought or manufactured. And then you're gonna say, well, the requirement we set for ourselves was we needed screws that are this size and this strength, and you're going to test them, okay? And if that should be really easy, because testing screws really more or less is just like, do they have the certification, right? You buy screws to a spec, and they're supposed to be certified to that, and if you have the certification, that most people call that good enough, right? Then you install your screws into the piston, or whatever higher level assembly, and you're like, oh, well, this piston needed to have this strength and needed to meet these dimensions and whatnot, and you test it. So you either measure it, or you physically test it on whatever, a vibe cable, you put different electrical currents or whatnot through it, you start doing sometimes destructive testing, sometimes not, right? And you test it at that level, right? So you test, and once it passes at that level, you build it up to the next level, so you put it in the engine, and you say, okay, well, our requirements for the engine were, you know, we wanted this much horsepower in this RPM, so now we need to make sure that that works, and then you test it, right? So everything that you created on the left in terms of requirements, all the goals you set, you check on the other side. You check. And there's going to be times where everything that you built up till then worked, but once you start putting them together, right? Once you start putting your pistons in your engine, suddenly something doesn't work, even though theoretically it worked in the beginning, on paper, on math. It was supposed to work. It was supposed to have 500 horsepower. And then you put it together and it's like, oh no, it doesn't have 500 horsepower. What went wrong? And what probably went wrong is on the left side when you were creating a goal, you missed something, so you needed to add an extra goal. You needed another requirement, and you didn't know that, so you didn't make it. And because you didn't make it, you weren't able to hit your 500 horsepower or whatever. So there's this whole like cyclic thing of you're supposedly trying to go down and then up like a normal V, but you're gonna have all these little loops where you end up going from one step backwards, one step, or back like to the other side of the V, and then you're gonna have to go back forwards again, right? That's the systems engineering V. In case anyone ever asks you about systems engineering, this is all you really need to tell them. You use pi as a 3 and not 3.14 the entire... I mean... Rax, have you ever seen the one homework problem that says estimate pi as 5? Have any of you seen that meme of it? It's like literally a math homework problem, and it's like blah blah blah, calculate the area of this, use 4 as your or 5 as your estimation for pi, and you're like, what? So this is what systems engineering is, mystery, and it's sort of weird because like a lot of people, depending on like what specifically you're doing, a lot of people will see this and be like, you don't even necessarily need to be an engineer to do a lot of this stuff. A lot of this stuff is like sort of management, right? It's sort of just like keeping things organized, making sure your requirements are broken down, right? So for example, you with our engine idea, right? If our engine was 500 horsepower, right? Supposedly, that's the idea, right? This has to, at some level, break down into like some chemistry of how much energy you're getting out of gas, right? So you're going to say, we expect it to use octane or whatever, and then we expect it to use a gallon per hour, a gallon per whatever, right? Per time, right? So this is like, there is a technical side to breaking this down, but you're not necessarily expected to know every little bit of this, right? The people who come up with the idea for the iPhone are not expected to know every little detail about every bit of processing speed about exactly what voltages, right, are going on, right? That's not something the person who started this at the top necessarily needs to know. And that's a sort of trend in systems engineers where, like, a lot of the things you work on, you're not necessarily going to be a super expert in, right? No one has all the subject matter expertise of the whole entire airplane where they know every in and out, from the strength of every screw to the computational fluid dynamics to the chemistry of the fuel. No one knows all of that. But you still need to have people who are doing the systems engineering, right? So what it tends to be is you have systems engineers who somewhat understand like conceptually what's going on is what you should aim for. And what they rely on is they rely on more technical disciplines to do the exact expertise of whatever they're looking for. So your systems engineer would probably, in terms of processing speed, ask both an electrical engineer and a firmware engineer and a software engineer for input on how to break down the speed of a controller or a processor in your car's speed controller or things like that. And because so much of it is like your systems engineer can't know everything and they're just basically going to ask other people to do a lot of work for them, we get like a little bit of a rap. Little bit of a rap for being sort of middle managey. Even 4 is more understandable. Yeah, I don't know. Pi is like a weird one. Who knows how people decide how to round? I mean, I think very practically, 3.14 is like, should be the gold standard. If you're rounding it to 3, you're probably like some sort of sick, or you like need to do mental calcs, but anyone who rounds to 5 is actually a sicko. You like to jump to the middle part, right in the middle of the V. So, interestingly, right, like, I know a lot of people like this. This is where you just start building. And that's a very valid style of engineering, right? The thing is, if you just start building, you have to be, like, really good at keeping organized. And that's sort of what systems engineering was intended to do, right? It's supposed to be like a sort of organizational structure. Thanks for the cat toggle, Gojo. Thank you. Gojo. Do you have systems engineers in your work? And if you do you think that they're productive or not? I know our software guys, like, why do systems engineers even get paid so much? They don't do any of the work. Papa Bell is like that. I told Papa Bell I was going to be a systems engineer for my first job. And he said, when I think of a systems engineer, I think of an engineer who can't build anything for themselves. But to me, I still think it's probably the coolest because I get to touch everything, to know everything, sort of, right? To understand at the big and small scales, to understand how one thing affects another, how the mechanical stuff affects the electrical stuff, and the chemical stuff, right? Yeah, I think it's just a pretty general, multi-purpose, sort of engineering. But I think everyone interprets it a little differently and everyone executes it a little differently too. I definitely know some systems engineers who are like really technical, and others who are like, they might as well be like project managers. They might as well just be managers at that point. Jack of all trades but still can't build anything? Well, frick you. Okay? We can build, some of us can build things, Brax. Some of us can build things. I can maybe, every once in a while, create something. But most importantly, I can sit in all the meetings and nod my head of like, I sort of get what you're saying. Oh, so the Visbar. The Visbar is like a reflection. Yes, I see. While our RF guy rattles on about, you know, different losses between converting RF to fiber optic and all sorts of stuff, I'm just sitting there like, huh, okay, so you're saying we need to do more calibration. Got it. That's all I needed to know. Add another requirement to the list. But also, I'm not that dumb. Sometimes I correct my subject matter experts. Sometimes they have it wrong, chat. I just want you to know that sometimes I know better than them. And it happens. Because everyone makes mistakes. Technicians have the same opinion about all the engineers. I mean, that doesn't surprise me depending on where you work and what you work on. I think part of it really depends on like what the engineers are doing. At one of my old workplaces, I know some of our projects had like union workers or different types of unions where just the way that things were, engineers like actually weren't allowed to pick up wrenches. So then you end up with engineers who all they do is they tell you what to do. And then because they're not like actively doing things, then they sort of become detached. But I was actually, you know, doing stuff in the trenches with our techs. So I feel like I had some decent respect because the project I was working on was like 10 engineers and 3 very specialized techs, and everyone had to do a lot of hands-on work. A wall with the engineer side and the shop side, that's the problem. If your engineers don't even cross the wall, you have a problem. Because every fucking time, chat, every fucking time a mechanical engineer designs something in CAD and does not watch it get assembled, an angel loses its wings, okay? If you design something, you need to be there as it's built, because there's like a solid 30% chance like things just don't fit together, or things don't seem right, and you need to step in and witness the mistake you've made so you can fix it, or help deal with it. Because some things are just not practical, and you won't even know they're not practical until you've done them, or you've seen them, right? When people are like, I had stuff that I was working on at my old job, where what it was like, we had you can think of it as like an extendable table, right? Where it had legs. Except its legs matched up with the bottom part that was like upside down, and they were like telescoping, so they were tubes, right? And so you had this like adjustable table type looking thing where you would move one and you would pin it, so it would be a different height. Here's the thing, chat. If all you do is you build something in CAD that's like, you've got your like square looking thing and you have tubes, and you're like, okay, we're gonna do this, we're gonna use a sheet of sheet metal, and then we're gonna do some rolled pipes or rolled sheet metal, and then we're just gonna weld them together and they're gonna fit perfectly, you're in for a ride, right? Because the second you start welding this, your sheet's gonna start warping, things are not gonna be straight, you're gonna end up with like, one of them's like slightly bowed like outwards. right? And then when you try and mate it with the top half, like the top half literally just can't slide in, or there's serious binding, you know? And that's stuff that, like, you just need to have work experience. You just need to have hands-on experience to recognize, because if all you've done is sit in front of a computer all day, you're not gonna know. Mechanical engineers believe steel is a perfectly rigid material? No, you're just wrong. I mean, that's not even, we don't believe that, first of all. You've just worked with people who've been lazy. The deformation of materials? Yeah. Just like I'm gonna deform your mom. Sorry, unnecessary. But I really think the key is to just be there at the end as, like, to witness the end user, right? The end user, both in manufacturing things and using them, because that's how you stay in touch, right? And even if you build something and it, like, gets fucked up while they're building it, it doesn't fit together, at least when they're trying to assemble it, right? When they're trying to assemble this wobbly table, if you show up and you're like, oh, I made a mistake. I'm going to adjust for this. I'm going to fix this. It looks way better than if there's just a bunch of text there trying to assemble something and it doesn't fit and you're not there and they're like, that one engineer, they have no fucking idea what they're doing. They don't even know the consequences of their actions, right? It helps to just show up, you know? Show face. But yeah, that's one of the things I learned at my first job is, like, if you're ever trying to design, you know, anything that's supposed to be assembled, you need to be there when it gets assembled, right? Just to at least oversee things, and you should design means to build it. Okay? So for my example, with this thing, right, if your idea is to build a part that's just like a sheet of metal and a bunch of tubes, what you need to understand is if you're gonna design this, you should also design a rig. Okay? You should design a rig where when they're welding those tubes on, they have some sort of clamp or structure that holds everything in place. How would I draw it? Some sort of clamp, plural, that, like, hold everything in place, make everything nice and snug, leave no room for errors, and that way, when they're just, like, welding, they just go to town. They don't have to worry about anything, right? You design all that for them. You design all the tooling for them, right? If you've got some really crazy, delicate PCIe or other circuit board assembly that has a really important connector, right? Really delicate connector that needs to get plugged in. You design something that holds things in place. Right? It holds everything in alignment, so the person assembling it doesn't have to be super worried about slipping. They just put it in the groove, and they push, and it mates perfectly. Easy. Easy. Someone's just like, bend it back. Hashtag project manager right there, right? I mean, the funniest thing was, I was literally hearing this the other, like, month, where we were working on some stuff that needed... I'll tell you, it was an assembly that had, like, electronics, right? And it had, like, an antenna, right? And one of the things was, like, the chief engineer was talking with the program manager, and he's like, oh yeah, I mean, in order for this to all mate perfectly, you know, we need something to hold the antenna really well while we run the test and all that. Everything needs to be perfect. It's gonna take a lot of design work, right? And the program manager was like, what are you talking about? It's just like a holder. And the chief was like, no, it's not fucking... You don't just, like, put it on and, like, bend it into position. Are you fucking crazy? Anyway, it's just one of those things where, like, you have to culture yourself. You have to culture yourself, chat. Just like you can't only live in the same city all of your life and then never understand what other people's day-to-day lives are like in, you know, the suburbs or the country or other countries, right? You want to see what the perspective is from other people. Engineering's the same way, right? Freaking electrical engineers are out here talking about, you know, oh, too much resistance, just make the wire thicker. Easy. Oh, yeah, easy. Anyway, that's my little rant. And my silly talk about systems engineering, because freaking half the people who I talk to about systems engineering are like, so you work in operations? You're a manager? What the frick? Like, what do? You don't even seem like you need to know math. You don't. What are you even doing? Why do you call yourself an engineer? And then other people are like, oh, so you know everything. And I'm like, yes, everything. But anyway, so systems engineering is like this management process for like the requirements and how everything ties together. Model-based systems engineering is using a program that more or less, it creates what are called models. So with our car example, right, where you need an engine, you need transmission, I didn't know I turned into Henya. I'm taking after my Kamiyoshi. You have a chassis, right? These are all, like, you think of, like, objects and objects-oriented programming where they all have traits, right? So your engine is, like, whatever size. It's whatever horsepower. It's whatever, you know, material, weight, whatever. Your chassis is the same thing. It needs some strength. Has some weight requirements. Your transmission obviously has requirements on how much force it can deliver, right? Force delivery. And all of those are related, right? So the idea is you have software that links them together, right? So that when different people are working on different things, and you need one team to be specialized in working on the engine, and they're like, can we make a change? Can we change the horsepower? And they decide to, like, change their idea of what the horsepower should be. It immediately transfers over to everything it affects. And everyone on other teams immediately knows, right? So everyone works out of the model, which is basically like a big file directory program type thing. And it should theoretically keep everyone constantly updated and constantly keep people on the same page of, like, what needs to happen. What happens when we change our operating system from Windows 10 to Windows 11 how's it gonna affect everything on our iPhone? How's it gonna affect, or what, not an iPhone, because they obviously don't use Windows, right? On our tablet or whatever, how's it gonna flow down across all of our subcomponents and affect everything, right? But the key to this working is that it only works if your model is built, right? Like, if you've properly linked your horsepower value on your engine to your force delivery on the transmission and the size to the strength of your chassis, right? You have to set that all up, right? You have to program that in. So, really being able to do MBSE is about properly managing all these links and making sure, you know, everything is correctly connected. And that way, whenever people make changes, it moves correctly through the model. And similarly, like, you can use the model for other things, right? You can model, like, if you designed an airplane that was supposed to go in, you know, 50,000 feet, right? And that was based off of, you know, its engine force and whatnot, its wingspan, blah, blah, blah. Then it's really easy to change that model to do 40,000 feet or 60,000 feet, because basically it's just changing one of the things, right? One of the values on your model, and then you can quickly see performance stuff for that. So, yeah, model-based systems engineering is like sort of programmy, block diagrammy systems engineering. That's what I need to study up for, right? Because I get this whole, like, requirements thing. I get how everything is interconnected, right? I understand, but in order to do these models in these programming languages, right? Like, the biggest one is what's called SysML. You need to understand, like, how the languages and how the tools work. Just like how if you want to build, if you want to 3D print something, you want to 3D print a shape, you need to know how to make the step file. And in order to get the dimensions right, you're gonna need to know how to make how to do it in CAD, right? It's a practice thing. It's a practice thing of, like, understanding how to properly do things in CAD and software. But yeah, that's what I've been sort of gunning to learn this, and I've been trying to get my manager to get, like, training organized for me and the other people under my manager, because it's a skill that I think is, like, really blowing up in especially bigger industries with more complex products, like aerospace, where you've got these fancy big ass planes. I think it's probably gonna show up more in tech, right? When you've got really complex phones and whatnot, in robots, you know, anything where you end up with just, like, so much going on that one person can't possibly understand all of it, it's going to start being more and more helpful, right? When you have bigger and bigger teams working on things, it's going to be more helpful. It's just more organization, chat. Although low-key, some people don't like organization. You know who I'm talking about. The people who are like, oh, I don't save past versions of my files. I don't have an organized file structure on my computer. I put everything on my desktop. Low-key me for real. Exactly. It's the engineers in the room who are like that is the problem, and that's why we need systems engineers. Chat, I'm not even gonna lie. My old computer, and my work computer for that matter, I store everything on desktop. And because on my work computer, it's like, I get 3 monitors, right? All my desktop icons are like mainly on one, but if I need things separated, I start moving them to the others, right? So that I can have like this specific space for whatever project. And then sometimes I like go home or something and I like unplug my extra monitors because I need my laptop on its own. And then all of those icons conglomerate on one small window on the on the laptop screen, and it's just freaking a cluster. Cluster frick. This semester you've been dropping everything on your desktop? Sicko. Sicko! Rax is disgusted with us. I am really curious right now. Seniors are probably like wrapping up their senior projects. I'm curious how a lot of those are doing. Okay. Do. I don't even know how I've yapped so much and not done any actual... I mean, I guess like talking about it is always helpful, right? Teaching is like one of the best ways to make sure you mastered a subject. You only have one monitor, but how do you manage to... Rax, it's fucking easy. Imagine this, Rax. Every time you make a new file, every time you take a screenshot, right? Because sometimes I take a lot of screenshots and then I draw on them in MS Paint. And then I'm like, where do I save this? Just goes on desktop. And desktop isn't that big. You just had your finals, mystery. How did you do? How did you do? Skill issue. I know rubber duck programming is like a thing that software engineers do, and I know that it's like useful, but I would feel silly doing it. I would rather just get a person. Get a person, Dio. Talking nonsense for hours? I haven't even been live for hours. But I'm glad I don't know if it's good or bad that you feel like it's been hours. Gojo? I don't know if it's good is that a good thing? Do you feel like you could spend eternity with me? Or do you feel like you're trapped in me forever? Trapped with me forever? This is purgatory. You might have failed a class, but you might be able to make it up over the summer. Okay. Summer courses, honestly, cheat codes. Chat, summer courses, cheat codes. Or classes that you can take at community college. I never appreciated it when I was younger. Younger me was all elitist, like, community college? Why would I do that? I go to a prestigious university. But now adult me is like, why would I take difficult classes like Chem Lab in university where I'm gonna get fucked by the professor when I could have done it at CC and it probably would have been an easy pass. Hook yourselves up, chat. Hook yourselves up. Make it easy on yourself. You sort of draw a mind map on paper, but the paper is never big enough. So you need a conspiracy board? Dude, you need to add all the strings that trace all around, and then you get to be like that guy from It's Always Sunny in Philadelphia who's like, conspiracy. Most of the community college classes you've taken are actually better. I think that really depends. I think part of it is because community college classes are gonna be lower div, I think is the word, right? And if you go to a university and you're taking lower divs, like you're taking math or whatever, you're taking Calc 2, your Calc 2 class is gonna be like this giant lecture hall where like the stadium is like the stage is like this and there's one guy and it's literally going to be like 300 people in there. He literally cannot cater to you all, and he probably doesn't care enough. But if you go to community college, that same class might be like, I don't know, maybe 40 people, depending on where you are. And that's way easier for them to help you, right? Way easier for that teacher to manage. So I think it can be. But if you told me I should take heat transfer at community college, I would be like a little bit suspicious. A little bit suspicious, Dio. What was I going to say? Oh, skill issue. I have seen at my workplace, like, I've actually seen some of the best documentation of my life written for programming, where it was like, they had like their main routine, which was like, run thing. And it actually was like boxes with arrows that showed what subroutines it called. So it was like sub A, right? The actual label of what it did. And all the arrows had numbers too. So it was like, it would do this first, and then this, and then this, sub D, sub B. I skipped C for a reason, because, you know, if you had sub B calling another thing, right? That could be sub C also, right? But this is really easy to read because you just start at the top and you're like, oh, it does number 1. Okay, and then it does number 2, but before 2 finishes, it has to do this, right? And then finally it does 3. And that was really cool to me. That's so much easier to follow than like tracing things through Visual Studio Code. You think of all these classes as a barrier to get to work, so you don't mind? I don't know if I agree. I mean, some of the stuff you learn in classes is actually very useful. The problem is, especially with El Undergrado, right? You need this. Especially with El Undergrado, what you learn is like really wide, and like you actually do learn like decently deep, right? But what you need in work is you need like specialization in one topic. Or maybe like a couple topics, right? And you need to really understand them. So what school does is it's really good at exposing you to everything, so that no matter what your job is, whether your job is working on back-end apps, or it's doing configuration management or something like that, right? Which would be a different set of spikes, right? Database management. Right? Or it could be some other thing, right? Who knows, right? You could be doing who knows, right? All of those are going to use slightly different skills, and you're going to want to be good at whatever you do. And what school is really good at is it just sort of like makes you aware of everything existing. Even though you're not actually like work grade on almost any of it, you actually will be work grade on like a couple things by the time you finish school, to be honest, right? I know students who are definitely sharper than like some of my professional colleagues, because during school you're being very rigorous and you're like working really hard to understand everything. And when you sort of grow up and become like a professional, some of that you don't need to do as consistently, so you like forget. You forget how to do calculus. or whatnot. Definitely not talking from experience. Definitely not talking from experience on that one. But it's cool because I feel like since I'm relatively fresh out of school, I still remember a lot of topics, and I can still correct people on random shit, right? We've got our chief engineer who's like, oh yeah, I've been working in this industry 40 years, blah 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 blah. And sometimes he still like doesn't understand the concept as well as I do, right? Where he doesn't know heat transfer as well because he never had to do heat transfer, or he doesn't really do heat transfer. But I still remember heat transfer, chat. I still remember heat transfer, which was like this specific block of the diagram. I still know, so I can do the basics. And then he'll be like, oh, I'm glad you know this, Belle. You love when you're halfway through a project and you somehow forget to do calculus and basic math. I like how you just casually lump those together. Oh yeah, calculus and basic math, they go hand in hand. You know, calculus is just a basic math thing that everyone should know. You like to learn by finding someone experienced and picking their brain? Yes. But here's the thing, Mystery. There will be a lot of subject matter experts. You can do that. But if you work in certain industries, there's also going to be things that, like, no one in your workplace is going to be a subject matter expert in. Okay? I just want you to understand that. Like, even in my workplace, right? Our building has like 400 employees. And one of the things that we work with is we work with fiber optics. You know how many fiber optics subject matter experts there are here? There's 0. So even though I only know like a bare bones amount of it, I still know like a good amount for what we do. It is kind of basic, Mystery. I mean, it really depends how you look at it. There was a time when I did think calculus was like very basic, and I was like, I will always completely understand calculus, and I understand it conceptually, right? I understand calculus conceptually, but if you ask me to do, you know, trig substitution, you ask me to do integration by parts? No. Veto. Right? You ask me to do partial derivatives with respect to, you know, whatever, or non-linear differential equations. Yeah, I mean, I'm just gonna ask Wolfram Alpha, you know? There are layers. One you get in 5 minutes, the other will take a day. Yeah, I totally agree with that, right? Because like I said, I understand calculus. Like, I understand just generally what integration is, right? And I always want to say derivation. It's like, that's like not the same as taking the derivative, or differentiation. Is that what it is? Whatever. The opposite of integrals. Derivatives. Like, I understand it, and I get it. Like, it's really easy to get at in 2 dimensions, and I also understand it in higher dimensions. I understand, like, the general purpose and how it applies to all sorts of things. I understand how it could apply to vectors that are, you know, 15 things long, right? But can I necessarily do it? Depends. I mean, sometimes. Sometimes I, like, there'll be something where calculus could be applied, and it is applicable, but you just don't see it until someone points it out, right? And that's what it really is, right? I think in college, when everything is calculus, because in college everything is calculus as an engineer, you sort of look at everything through that perspective, and you can always see, oh, I see how this is calculus. I see how the power draw here is calculus. I see how the forces turning into moments is calculus. I see everything I can see how it becomes calculus. But when you stop using calculus, you stop drawing those analogies. So there's a lot of things that I think I work on that probably could be calculus, right? And I could apply calculus too, but I'm just not familiar enough anymore that I don't immediately think of it. Yep. You only know what's needed for materials and structure of them? Yeah, I mean, like I said, I sort of only know very basis levels of a lot of things, right? I know, really basic ideas of chemistry, how batteries work, right? How charge works, how charges move, and you end up with charge sharing, and how that affects things like capacitors, right? But you ask me to, design specific circuits that discharge at a very specific rate and blah, 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 blah. You ask me to do, Norton equivalents, right? Or Thevenin equivalents. I could do that shit in college all day. I could do that I was easy peasy. I'm the princess of equivalent circuits. I saw a question about Thevenin equivalents the other day on the engineering student subreddits, and I was like, oh yeah, I could probably do that. And when I thought about it, I was like, wait, I don't remember how to do this. Those suck. Mystery, you are an electrical engineer. That should be engraved into your bones right now, Mystery. That should be engraved into your bones. Just okay. Voltage dividers should be engraved in your bone. Right? You should know that like the back of your hand. And I'm only saying this because I have a couple of electrical engineer friends who I think this was a while ago where they talking about it, but they were still relatively fresh out of school, right? They were only a year out of school when they were talking about it. But they're oh yeah, I needed to do a voltage divider the other day, and it took me a while to puzzle out, and I was like, Girl, this should be in your soul. It's in my soul. I was a fucking mechanical engineer, and I can do voltage dividers like the back of my hand. Your professor always makes them super hard. Mystery, I can guarantee you the shit you'll see in the real world is hard. Do you think... Okay, you don't do truss analysis because you're EE, but I was mechanical engineering, and they did what's called truss analysis, right? Which is for bridges. You start with bridges that's supposed to cover this distance, and the idea is you have all these trusses that you just treat as a beam, right? So it's either in tension or compression, and they make these shapes, right? It's very, very much, you can very much see exactly how it applies to the real world, right? Where all you're doing is you take what you know about different loads, so you have a 5,000 pound load here, and some supporting column here, and you've got support here, and you should be able to do analysis of all of these and know exactly how much tension or compression any single member of them is in, right? That you can... I know I had fellow students who were oh man, it was so difficult. The truss was all sorts of weird shapes, with one being big and this one being small. You know, you've got like some weird shape, right? They are like, oh man, that's so complex. I had so much trouble with this problem breaking it down. Bruh, this was only in 2 dimensions. Real world bridges are gonna fuck you up, chat. Real world bridges are not purely in tension and compression. If you can't do this, the real world is gonna fuck you up if you need to do it. Now, I'm not saying everyone needs to do it, right? Not all mechanical engineers need to know how to do trusses. But the people who are building bridges, they're doing a lot harder shit than fucking we were doing in college. And that's like exactly what the like Thevenin and Norton equivalents are, is like, you might not need them wherever you work, but if you need them, they're gonna be fucking crazier than anything you've seen in school. And they're using CAD. No. Don't say that. Don't pass that up. Before you do CAD, I need to emphasize this to you. Before you do CAD, you need to do back of the envelope calculations. Because if you get too reliant on CAD, right, and you end up hitting some singularity where it ends up like messing up its rounding errors or whatnot, you're gonna get fucked up. Chat, you're gonna get fucked up. or you set your boundary conditions wrong and you don't even know it, right? You're not even gonna know until it's too late. That's why you have to do back of the envelope. It's the exact same thing as what you were talking about, like, oh, engineers are so bad, technicians hate engineers, engineers design things that never fit together because they like look at it and in CAD they see a thing that looks like this and a thing that looks like this, and they're like, oh yeah, it's 2 sides of the tube, they should just mate together, they should just screw together, everything fits in CAD, and then it like doesn't, okay? It fucking... Remember, you are stronger than the machine. You are stronger than the machine. And it's funny because in a lot of ways you're not, right? I'm never going to be able to do calculus the way Wolfram Alpha does. But I'm gonna be able to understand things at like a scope that Wolfram Alpha isn't smart enough to do. That people only hope AI can do, but no one's trusting AI to design bridges, chat. Yeah, I mean, it makes me think of, I took a class however many moons ago, about over a year ago now, that was like all about digital logic, right? Where you have your high voltage, or I guess it's technically what, VDD? VDD. And then you've got your ground, right? And then you've got various transistors, right? That do different sorts of logic, and that gives you your output. And like a lot of the homework and whatnot, the professor was like, oh, you need to use cadence. You need to use CAD to do analysis of it. But it was really helpful learning it by hand and understanding, like, by hand how cadence does its calculations of, like, how much current is going to flow through this? How much time is it going to take to charge this capacitance? Right? And then from there, you can start designing your FPGAs and whatnot, all your fancy stuff, right? You start doing back-of-the-envelope calculations, just knowing general physics. I'm not even a fucking electrical engineer. I'm a dumbo systems engineer. Dumb. Break it dumb. break a dome. I think it's funny I had this on hand. You think they copy and pasted an old design and played video? Honestly, like, you know, right? You know that all they do is they just reuse the slides from last year. Of course. They reuse slides, they reuse homework. Right? They might tweak a number here and there, but they're definitely not writing a class for you every quarter. Or every semester. Of course not. In fact, I'm pretty sure if you just became a professor, you start as a lecturer in college for the first time, and they tell you, oh, we want you to teach circuits 101. I'm pretty sure they give you the previous teacher's slides. They give you the course curriculum. They're not just like throwing you out into the depths to just do shit however you decide. But the job of the professor isn't to write all the shit, it's to like be able to, you know, properly convey it and to support questions. That's what you're paying for. If all you wanted was write-ups, then you didn't need to go to college. You could have just Googled papers. Some dude designed a vertical lift bridge, ended up putting the lift mechanism backwards, put bolts that made the mechanism too stiff and broke. I hope it wasn't an important bridge. But it also reminds me of like fucking. You guys see all the know of like all the stories of weird wonky engineering designs. I think there was one that I remember that was like, it was like 2 towers and they had this bridge in between. And what it was like, the bridge was supposed to be, if I remember right, it was supposed to be supported by like bolts where you had beams that were bolted together like once or twice. And what they ended up doing when they actually built it is they put in like an extra bolt, which probably to most people sounds like it should be good. You're just, you know, you're adding safety factor. Easy, the bolt's less likely to break. And then what that ended up doing was that like fucked with the stiffness and it caused the thing to collapse. Right? Doomed. Because people just were like, fuck it, we'll add extra bolts. Easy. They fit in CAD. Easy, they fit in CAD. You know, I think it's always really important to at least do a once-over of your work with the pen and paper and be like, maybe the CAD was wrong. Chat. I've actually not studied at all since I've been on stream. I've just yapped about engineering. MBSE Training arc my butt. I've just sat here with the PDF open while I talked with you. How stupid. How stupid. And now it's fucking 9:20. I don't really want to study anymore. Semi-working stream? Yeah, it's me working on explaining stupid shit to you. And it's not, for the record, it's not stupid shit because I don't need to explain things to you because you're stupid. It's stupid shit in that, like, who cares? Rax has been sitting here the whole time like, this engineering stuff is mumbo jumbo. I'm just here for the big titty anime girl. Two walkways supported by the same suspended thing? Yeah, I mean, I know. There's like all sorts of weird things about bridges. right? I'm pretty sure there are like tons and tons of like famous bridge issues where things just didn't hold up because they weren't designed properly, right? Someone didn't do their basic analysis. Rest in peace, their career. Imagine, like, if you're the engineer who stamped off on a bridge, you're the literal PE, right? In order to build bridges, you have to have my title. You have to be a literal PE in I think it's civil. Civil engineers have to do the PE stamp on that. If you were the PE who stamped on a bridge and the bridge fucking collapsed, you're done. You're probably going to prison. Like, your career is for sure over. No one's ever hiring you again, but you're probably going to prison. Having someone nerd out is really entertaining. I'm not nerdy. I'm just passionate. Just like your mom. How did we get here? Talking about PEs and stuff. I don't even know why I'm a PE, chat. I think I spent $300 to get this fancy PE title and took a bunch of tests and whatnot, and now I get to be like, yes, indeed, I am a state licensed professional engineer. But I never intend to work anything ever where I have to stamp something. If someone's like, we need you as a PE so that you can stamp off on this, I'm literally going to ask them for triple pay. That is so scary. That is so scary. You're so liable. Have I seen the TV show of engineering fails? Which one? Is it one specifically about engineering fails? Or I remember, I don't even know why I'm thinking of it because it's not necessarily engineering fail. Do you guys remember like that one scandal of, I think it was called Thanatos? And it was this lady who ran a company that, like, they claimed to have made a new small blood tester where all it took was a single drop of blood and you put it in the tester and it could test you for all these things that normal machines would take like days and they would need like a full vial of blood. And she was like, yes, indeed, this is the future. This is the future of blood testing. And she got a whole bunch of investors, and it turned out to be like a huge fraud. They would do tours, and they would have like a demonstration where the people got pricked and they took like a little bit of blood and they put it in the machine, and then they walked to another room, right? The tour would go to another room. They'd be like, oh yeah, we'll come back in an hour for your results. Some poor guy would frantically run into the room after they were gone, take the vial, or not the vial, the little sample of blood, and run it to the other room that had like the actual normal testing machines and attempt to test it, but would still get it wrong sometimes because they didn't take enough blood. That's what I think of. That was like a crazy conspiracy to hear about, because she like managed to fuel a whole bunch of Silicon Valley folks. She had like millions of dollars. I think she had some crazy thing about Steve Jobs, so she like always tried to impersonate Steve Jobs, like wearing his like sweater or whatever the frick he wore, right? I remember she talked in a really deep voice and people were saying, oh, it's a fake voice. She fakes her voice because she wants to seem more authoritative. She probably was smart enough to have a very promising normal biomedical, engineering career, and then she went off the rails just trying to become the next Steve Jobs is what I hear. Chat, I'm all for an ambitious woman, but fucking, why you gotta lie about stuff that's gonna affect people's health? Why you gotta do that, chat? Like, as much as I want to be like, yes, I'm the best aerospace engineer that's ever lived. Yes, I know everything. I'm not gonna fucking clear planes to fly people on them, because if the plane fails, people die. And I don't. What did she think was going to happen with this fraud blood testing thing? Chat. What happens when someone's like, "Oh yes, I need a test for HIV," and you're wrong. You give them the wrong result, and then they end up going and spreading HIV all over the place. You know how fucked up that is? That's fucked up, chat. Desperation makes people do strange things? I mean, I guess I get it. But I'm not that I've done any strange things when I was desperate ever before. Nope. Nope. Never anything weird. She thought a bunch of tech bros would give her money. I'm still conflicted, like, do you think she was delusional enough to think that they would actually get it working? Or was she just planning to try and keep the con up her whole life? Because I feel like she had to know better. She had to know it was, she for sure knew it was a scam. But like, was she delulu in thinking that eventually their engineers would figure it out? I mean, I heard things like, it wasn't even about engineering and that just what they were trying to do was physically impossible. No Man's Sky type situation? I don't know what No Man's Sky... Wait, what is it? What's a No Man's Sky type situation? But what I'm talking about is like, I remember hearing one of the things that they were talking about was like, your normal test for something might require 100 milliliters, right? And how they would test for it is they test for the density of something, and in that 100 milliliters, you might have 50 particles of it, right? And that's your diagnosis, is like, oh, you have, 50 particles per 100 milliliters. And they promise to be able to do it with 1 milliliter. And of course, like, you're never going to know, right? Because this 1 milliliter, if the person has this disease, right? If the person has this disease that causes these particles in their blood, like, you might sample a milliliter that doesn't have it, even if the particles are in the rest of it, right? Because it's literal just molecules. You're literally counting molecules. And so people were saying, yeah, you obviously can't do this test with that little blood. It's physically impossible. You just won't have any level of precision. They secured a ton of investment and couldn't deliver. Mood chat. Sometimes I'm like, why is my company not paying me a bunch more money? And other times I'm like, I really scored in getting a really big initial salary. I don't think I'm necessarily meeting their original expectations. They should always pay me more, chat. They should pay me at least 1% of what Elon Musk makes. I can do at least 1% of the work that he does. I can probably do more because I have actual engineering experience and I'm not a fake fraud whose only contributing idea was the Cybertruck, which is a piece of What? What? I didn't hear anything about Cybertrucks being pieces of piece of They can barely test for glucose with a drop of blood. Exactly, Rax. Exactly. I feel like she was maybe some sort of delulu. But now she in prison. Now she in prison. Where is she now? I'm only doing this because I don't know why I hit the wrong button. But where is she now? In prison, chat. Where she belongs. Did she get out? I thought she was supposed to be there for a long time. Let's check. Thanatos CEO. Theranos. Oh, Theranos. Elizabeth Holmes. Chat, she was a fucking Stanford student. She had so much potential. Her trial case, she was sentenced to serve 11 and a quarter years in federal prison beginning on May 30th, 2023. That means she shouldn't get out until mid-2034? Yeah, I mean, look at her face though, chat. Look at her face. There's something you can tell in the eyes, chat. She's got some crazy eyes. Well, crazy eyes. Crazy eyes. She's a rich person and rich people don't go to jail for a long time? May be true. I don't know if I think she's that rich anymore because I think they took all her money. She was sentenced to pay $452 million. Definitely too much white showing. You're talking about the eyes. Like her eyes are open too wide, like this. Or maybe more like this. It's so lucky that I had this pulled up just coincidentally before stream. It's perfect. It's perfect, chat. Holy shice. Holy shice, chat. It's 9:30 already. I don't want to work anymore. I don't want to work. I just want to sit here and yap to you guys. But like, do you think crazy people end up rich, or they become crazy after they become rich, right? Do you think this lady was like always a psychopath, or you think the money got to her? Like, after? Wait, she went crazy after she got the money, is what you think? Or she got the money after she was crazy? She pulled a Kanye and became famous, and then the money seeped into her brains and caused the delulu? Crazy people can gain money easier. Is that true? Then I want to be crazy. Chat, this is a stick-up. Hand over your wallets. Hand over the bits. Just a joke. Just a joke. Don't spend the money, Gojo. Save the money for your food. Gotta save it for the recession. Before the crazy was brilliant, but then it went wild? I don't know, chat. Too broken? Exactly. Fucking the R word, the recession word is no es bueno. No es bueno. Chat, how much do eggs cost where you live? Spend the money on a chicken? Where the fuck am I gonna put a chicken? I live in California, in apartments. I don't have fucking a space for a chicken that's reasonable. I mean, I guess I could keep it... I was going to say I could keep it, like, indoors, I guess, but, like, then, like, don't they need to graze? Don't they need, like, grass or some shit to peck at? 50-cent Australian coin? Why do you have Australian currency? Huh? Is that from just last Tuesday? Tuesday? How, someone teach me to speak Aussie. You got 12 eggs for $4.76. Americans, how much are your eggs? I feel like that's pretty reasonably priced. Like, $4.76 US seems, I would almost say cheap, but I don't know if I'm fucking delusional. Out of touch. $4.76 for a dozen seems pretty solid. You don't buy eggs, Gojo? Me neither. Hashtag no cook gang. Hashtag no cook gang. When we cook, it's met, huh? I didn't say anything. I used to cook, chat. I used to cook, and by used to cook, I mean I, like, made salad and shit. And I realized even when that's, like, all I was making for myself, I would sometimes, like, it would sometimes go bad. I just, like, couldn't eat enough of the lettuce in time before the veggies started going bad. Or, like, the onion, right? Because I like salads that have good variety in them, with tomato and onion and crouton and all the, like, nice, crispy, you know, refreshing goodness. And so I would chop onions so I could have onion in my salad. But, like, what? You have to buy a full fucking onion, chat. You know how many salads you need to eat to use a full fucking onion? And I don't really feel like I should be having a chopped onion for more than a week. Right? Like, I feel like you probably want a chopped onion to be in that state at most, like, a couple days in your fridge, right? But I'm not eating that much onion in, like, a couple days of salads. I'm not some psychopath who has more onion than tomato. Or more, God, definitely not more onion than lettuce. You'd have to be, that would be a true psychotic, chat. Find me someone who has more onion than lettuce in their salad. And I'll show you someone with no taste buds. That you cut a half and throw it into the fridge to cook later? Okay, you say half. That implies I'm going to use half right now. I'm not using half an onion on my salad, Rax. Half an onion is like so much. At most in one salad I'm eating like an eighth of an onion, I feel like. Right? That's like, you chop the top. I guess I should go back to this. You have your onion. And it's like onion shaped. Hey, that was pretty good, actually, chat. And you chop it once, twice, and then like a third time, like in this plane. And that puts it in the eighths. And then I would eat like one of those, maybe, per salad. Yeah. I mean, I am going to cut it like in half first, Rax, but like, what am I I'm only going to eat half half of this part, that leaves so much more. That leaves so much more. Like, what am I gonna do with it? What am I gonna do with all the onion? Right? And if all I eat are salads and I just have like a salad for dinner every night, then that's 1 day, 2 days, or how should I do this? 1 day, 2 days, right? Because you have like the front of this, front, and then the back half of the same spot, and then same again, 3, 4 for this quad, and then 5, 6, and then 7, 8. Onion rings? Dude, do you know how, like, is it easy to fry shit? Do any of you know how to fry onion rings? That sounds so good. I don't know if that's healthy or not, though. Probably not, right? Even though it's homemade and it's fresh onion, probably still not healthy for you. But, chat, why you gotta talk about onion rings? I started a diet 2 days ago that I'm gonna have to hold for the next 3 months. At least 2 months until off-kai, so I can have a cute summer body for off-kai. Why you guys gotta do this to me, chat? I've only been dieting for 2 days, 2.5 days, and I'm already feeling the hunger get to me. And now Rax is out here talking about fucking onion rings? Chat? Throw the onion in the freezer and defrost what you need for each day? Skill issue. I want to correct. Part of me wants to immediately slam to correct you because I understand that, like, I'm the adult in this relationship and I should understand better than you. And my heart tells me, my biology understanding tells me that, like, since onions are plants and plants have that fancy thing called the cell wall, right? That what happens when you freeze them is all the water inside crystallizes and expands and breaks the cell wall, and then you end up with like something mushy or something bad happening to your onion. That's what my heart tells me happens, because I know that happens for bananas. Pro tip, chat, if you're a banana eater, I've come to understand is you freeze a banana, you then thaw it, and then you eat it. Because this exact same thing happens where you've got your banana, and it's got all its, like, cells, and you freeze it, and the water, like, punctures the cell membrane, and then the innards of the cells go everywhere, and it spreads the sugar more evenly, is what I heard. Try it, chat. I'm telling you to try it because I haven't had bananas in, like, forever, but that's what I think I heard somewhere, and I think that sounds pretty right. But can you imagine if you did that with an onion? Same with carrots, corn, beans, and grapes? Wait, so all of these things you, like, they have this thing where you freeze them and thaw them, and that, like, fucks with the mixture of water and sugar, and they get all delicious? I know frozen grapes are their own amazing thing because, you know, fucking freezing grapes is sick, chat. I wouldn't even thaw that. I would literally just freeze it and eat it like frozen, right? Because you like, no, you like chew into it like it's like, it's not like hard, right? It's got like that consistency of like, almost like snow coney consistency where it like breaks into little chunks as you bite through it. Chat, if we're talking about frozen fruit though, the goat is cherries. Frozen cherries are the goat, the absolute goat of frozen goodness, because like their texture becomes so perfect where you've got like your cherries, right? And then you freeze them, and they become this perfectly, like, just the right amount of solid so that when you, like, bite into them, this is your teeth. They, like, perfectly cut the cherry, and then the pit. What color do I use for the pit, chat? Orange? And it's a perfect, solid cut. There's no mushing at all. It's just like digging into the flesh of the fruit. Yep. Delicious. Hands down, best frozen fruit. Hands down, best frozen fruit. Although, I haven't tried some. I wonder if, like, my general favorite fruit is mango. I feel like frozen mango could be sick. Right? Has anyone tried frozen mango? Do you guys think it would? I feel like frozen mango could go hard, right? Especially if you do the like... I guess this is how normal people eat it, but that's not how I ate it. I almost never eat, like, mango the way where you, like, chop it, and then you've got this, like, mango bowl, and you use your spoon to, like, dig it out of the mango bowl. You guys know what I'm talking about, right? I think that's considered, like, the normal way to eat mango. But that seems like it would go super hard. Super hard if you froze it. It's like eating, like... I almost want to say it would probably be like eating mango sorbet. Delicious. Yum. Makes me think of Dungeon Meshi, which I just started watching recently the other week. But how I normally eat my mangoes... You guys maybe also know, like, this method, right? Where you have the mango, and what you do is you, like, score it, right? You do, like, this, like, crisscross applesauce chessboard pattern. And then what you can do is you can, like, flip it inside out. And then it's, like... this, like, hedgehog-looking thing with, like, cubes of delicious, meaty mangoiness. And then you just, like, go sicko mode like a dog, and you just literally just eat off of it. Like a savage. Any tahini? No, I've never really tried tahini. Is it spicy? Is that what tahini's supposed to taste like? Spicy? It looks like it would be spicy. It's all red. Chili lime salt? I don't know. When I think mango, the reason I like mango is because mango is like the embodiment of sweet. Chat. I'm never letting you send me gifts because I don't want you to have my address. But if eventually, for some reason, you develop the ability to send me gifts, send me sweets because your girl's got like crazy sweet tooth. Candy is the way to my heart. Sweet and spicy? I don't even know if I like sweet and spicy as a combo. Like, I'm trying to think of, like, when I like spicy stuff to also be sweet. I guess, like, some wings are sweet and spicy. Some of them chicken wings. But I don't even feel like that's my go-to. Actually, I lie. I like barbecue sauce, and I like spicy barbecue sauce, which is basically sweet and spicy, right? Barbecue sauce is like sugary. I guess, though, that depends on where you live. Y'all, what sort of flavors do you guys think of with barbecue? Like, I feel like barbecue here in California tends to be, like, thicker and a little bit sweeter in terms of the sauce. But I lived in an area on the other side of the country for a little bit, and what they liked for barbecue sauce was, like, vinegar-based. They like vinegar-based sauces, and I was like, I don't like the taste of vinegar at all. Do you like sour? Who wants sour meat? Who likes freaking pickles? sickos. Y'all sick in the brain. I think I also knew when I was there, I had a coworker who was Texan. And he was like, no, no real barbecue. You need real tried and true Texan brisket. Mwah. Barbecue sauce just ruined it. Mwah. It was some sort of American elitism right there. I guess I'm sort of the same way though. You should try Texas barbecue dry. I would if I ever go to Texas. I'm not sure I ever will. Maybe if I have like a work trip. But I don't think I would move to Texas. I know this weekend was WeebCon there. A certain star from the future was there at WeebCon. You know, although she's like always there. But maybe one time I can go to WeebCon or something like that and try it then. But dry barbecue just doesn't sound like you don't mean the meat is dry, right? You just mean not sauce, right? Because as soon as I think dry meat, I'm like, meat should be juicy. I like the dark meat chicken nuggets. Or is it white meat? I like the juicy one. I think it's dark. Dark is the, like, juicy part, right? The bark is dry? Why are you fucking referring to meat skin as bark? I mean, like, it's bad because I know what you're saying. I understand what you're referring to. It's like that outside part of the rack of ribs where it's all like a chunk, right? I guess it's sort of barky, but like, I can never unhear it now. Never unhear the talk of like meat being bark now. Now I'm gonna look at every rack of ribs as a fucking tree. Do you like eating trees? Get enough fiber in your diet? Now I want barbecue, chat. You guys are ruining my diet. Diet over. No, I have to stay strong. After stream, I'm gonna make myself a protein shake and sit in the corner contemplating my life decisions, trying to lose weight to get on my bikini body for the summer. Barbecue diet? I mean, I think some people do protein diets, right? Does that mean a lot of meat? People say meat is protein, right? So can you have a diet that's just like straight up meat and veggies? Get a bunch of steak in there? Sounds like a recipe for high cholesterol. Oh, ribs sound so good. But even if I could have steak, right? I feel like, I'm gonna be honest, chat. Steak is kind of mid for me. I definitely prefer ribs. Like, if I'm thinking of barbecue, ribs is what I'm thinking of. And ribs need sauce. And sauce is going to be fucking so many calories, chat. Barbecue sauce is gonna be like sugary, delicious goodness. And that's gonna fuck up the high protein diet, because that's gonna be like all carbs. I don't know. That's probably some sort of sick diet. Sicko barbecue diet, though. Reminds me of, like, you guys know about, like, the Oreo vegans? You have to control most of it with exercise and rigorous meal times. How much does the meal times matter? Because I hear such conflicting things, right? Like, I hear about some people who are like, oh yeah, what works best for me is I eat small 200-calorie meals every 2 hours or something. Or small snacks every 2 hours, and throughout the whole day my metabolism is burning, and because I'm just constantly eating, I'm never really hungry, right? I hear people like that, and I hear people the complete fucking opposite who are like, I intermittent fast. I only eat during these 6 hours in the day, very select 6 hours, and outside of those hours, only water. Only water. Intermittent fasting is the best diet for you. And those are like as opposite as you can get. One person is just constantly nom 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 nom, and the other person's like starve. Solitude, starvation. It's mealtime. Nom 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 nom. Nom 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 nom. You usually snack and eat when you want to? So do I. But I just want to look better in my summer outfits, chat. I just want... When I go to the pool, when I'm at the hotel at Offkind, I want to look cute, you know? You know? It's like a sacrifice you make for the sake of other people. You guys know about like Numi, right? Numi is like a strict dieter from my understanding, so that she can look fucking really, really good for her fans, if you know what I mean. She's got like abs, I thought. You keep away from snacks for most of the day as long as you're ingesting X amount of calories? Yeah, I think it's like... It really is just calories in versus calories out, right? As long as you're working off more than you're eating. But I also hear like it's really hard to do significant amount of damage with your working out. Right? Like if I ran for a full hour, that's only 600 calories, chat. And 600 calories is like sort of a lot, but it's also like so little. 600 calories is like, if you look at that in food, that's like not that much food, chat. American food is fucking crazy. Like, I think burgers can be like 1,000 calories. Burgers can be like 1,000 calories, chat. Sneak peek? No. Although, chat. Shit, maybe I've been so reluctant to commission art because part of me is like, why pay artists when can draw myself? And then I end up drawing for myself and it looks fucking stupid as head empty. But like, what if I commission a bikini pic, chat? I could go for some bikini pics. Summer outfit. Belle on the beach? Ayo, chat. Ayo. California Belle incoming. California girl Belle incoming. Me by the pool. Me with the super soaker. And the floaties. Now I have to look into it, chat. I need to find the best artist. Low key though, I feel like half the artists I follow on Twitter are spicy artists. And I don't know, I feel like that might be risky to commission something from one of them. You never know what you might get. Life's like a box of chocolates. Some are sweet and some are spicy. Some are sweet and... I mean, you say it's better, and I feel like it might be better. But I also know some of the people who are following me on Twitter, you know, follow me not because of my adorable, beautiful looks, but because I'm supposedly some sort of STEM person, engineer, something. something. I'm supposed to do some sort of engineering sometimes. Like I was supposed to tonight. Supposed to learn about MBSE. Maybe this weekend, chat. Chat, what if I study up a ton and we build a model together this weekend? That would be pretty cool. Bell as an OL would work? What's an OL? Don't tell me that stands for what I think it stands for. What does it mean, Rax? Answer. Oh, whew! I thought you were gonna say old lady. I thought you were gonna say old lady. Thank God. I guess you would have just said hag. But I guess Belle as a hag is just Belle. So maybe not that bad. Aren't STEM majors some sort of dweeb? Are you a dweeb, Gojo? Answer me. Answer me. Do you consider yourself a dweeb? Would you have bullied your high school self? You would have stuffed your high school self into a locker? Probably. How mean. How mean. What the fuck is a STEM major? I was trying to think of a D's nuts joke starting with STEM. But I couldn't think of one. Majoring in the stem of your mom's... Wait. This... Majoring in the stem of your mom's pee-pee. Man, I don't know why you guys follow me. I'm so bad. It's not even funny. But Rex, STEM stands for science, technology, engineering, math. So basically it's all the like science-y type things. Stemming on your balls? Frick. What does that even mean, chat? What does that even mean? Also, you have the break a bonk emote and it's just me swinging the wrench and like, I have to imagine the idea of balls being just destroyed by the wrench sounds. That sounds like it would be painful. Can you guys imagine it? I've only heard the stories. Only heard the stories of pain from getting hit there. I imagine though, low-key chat, low-key, I imagine it's not that bad. Have you experienced a period before? Huh? It's literal necrosis in your body. Yeah. No es bueno, chat. Okay. It is fucking... Oh my god, chat. It's fucking 10 p.m. I didn't even play the game I wanted to play. Chat, we're gonna play some games this weekend. We're gonna play that new half-sword game where I just want to chop people's fucking heads off. But until then, I think I need to call it for the night. I need to go and make myself a protein shake and try and imagine that it's a half slab of barbecue ribs because you guys have incepted me with barbecue ribs and onion rings. You've experienced Well, I hope it turned out all right. I hope you were into it. But anyway, chat, we're calling it here, but stay for the raid. It's raid time. I know who we're raiding. I should buy a fryer? For balls? or do you mean for ribs? I can't imagine fried balls would be very good. Anyway, chat, we're rating Misa. We're rating Misa. Be good raiders. She's super cute. She's got the cutest Aussie accent. It's just another Tuesday for her. Just another Tuesday. Crikey. Crikey. Throw another Bobby on the grill. Alright. Be good raiders. Say hi. She's super cute. Super cute. Give her likes and follows and whatever. Okay, bye-bye. Have a good night. See you this weekend. Bye. Bye.
Welcome in as well. Have you